We continue with finding absolute maximum and minimum values of a function on a given interval. Of course, having a graphing calculator is very useful in problems like this, but we're going to take a calculus-based approach first, and once we have a reasonable explanation, we're going to move on and verify our answers using a scientific calculator. So the very first step is to find the derivative, which is f prime of x. The derivative of x is 1, and the derivative of 1 over x is negative 1 over x squared. So we would have 1 minus 1 over x squared. And if we look at it, the domain of the function is 0.2 to 4. So the domain of the derivative is also 0.2 to 4. So the next step is to find the critical values. Or critical numbers. So we find that by setting f prime of x equal to 0 and solve for x. So we would have 1 minus 1 over x squared equals 0, which would imply 1 equals 1 over x squared. So x squared would equal 1. Since x squared is equal to 1, x would be equal to the square root of 1, which would give us plus or minus 1. And we needn't worry about minus 1 because it is not in the domain of the function. So we exclude x is equal to minus 1 because it is not in the domain of the function. So all we have is x is equal to 1 as a critical value. So we want to know if that particular value is a maximum or a minimum. So what I'm going to do is I'm going to plug in the end values. So f of 0.2 would be 0.2 plus 1 over 0.2. That would give me 5.5. Oh, 5.2, I'm sorry. And I'm going to plug in 4, and I have 4 plus 1 over 4, and that is 4.25. So it looks like we start at 5.2, and it is coming back to 4.25. So at 0.2, we have 5.2, and at 4, we have 4.25. So that would tell us something about the critical value. The critical value happens at 1. So it's somewhere right over there. So 1 is right there. And let's evaluate and see what the value of f of 1 is. So f of 1 would equal 1 plus 1 over 1. I get 2. and 2 is way below 4, so let's say that is 2. It's not drawn to scale, so it seems like the curve is going that way. So we have an absolute minimum at x is equal to 1, and the value of that absolute minimum is equal to 2, and the absolute maximum is at x is equal to 0.2 for this particular function. Let us see if we did this properly. We can make use of a calculator to verify. I have x plus 1 over x, and I'm going to set the window 0.2 all the way up to 4, and I'm going to set the value between 1 and 6. And you can see that my graph looks very much like what the calculator has. And I didn't even have to use the calculator. All I did is a bit of calculus. So first derivatives are quite useful in finding such minimums and maximums of a function. Here we have another example. And the very first step is to find the derivative. So u is x, v is x squared minus x plus 1, u prime is 1, and v prime is 2x minus 1. So we have to use quotient rule. So f prime of x is x squared minus x plus 1 squared. V u prime minus u v prime. And that would give us x squared minus x plus 1 minus 2x squared plus x divided by x squared minus x plus 1 squared. The x's would go away. I could combine the x squared and negative 2x squared. That would give me 1 minus x squared divided by x squared minus x plus 1. And the domain of the function here is 0 to 3, which would imply that the domain of the derivative is also 0 to 3. Now we are going to set the derivative equal to 0, and we will find the critical values. So we would have 1 minus x squared divided by x squared minus x plus 1 squared. If you cross multiply, we would have 1 minus x squared equals 0, which would mean x squared is equal to 1 and x is equal to plus or minus 1. And we are going to exclude x is equal to minus 1 as it is not in the domain. Now let's say if it corresponds to a minimum or a maximum. By it I mean the critical number x is equal to 1. So to do that, we are going to evaluate f of 0. F of 0 is 0 divided by 0 squared minus 0 plus 1, which is simply 0. F of 3 is 3 divided by 3 squared minus 3 plus 1. 3 divided by 9 minus 3 plus 1. 3 divided by 7. And that is probably 0.42 something, 42587 perhaps. We could find that here. Yes, 42857. Now we will evaluate the function at the critical number and see what happens. So 1 over 1 squared minus 1 plus 1, we get 1. So when I graph this, start at 0, and when I get to 3, I end up going to 0.42857, and at the critical number, which is 1, I am reaching 1. So my guess is that the function is going to go in that way. So that value is 1, that value is 0.4287. So x is equal to 1 corresponds to an absolute maximum. And the value f of 1 is simply 1. And absolute minimum is at x is equal to 0. And f of 0 is simply 0. Let us see if that is true. So we have x divided by x squared minus x plus 1. Set the window 0, 3, and minimum is 0, maximum I'm going to set it at 2, and my graph looks very much like what the calculator is telling me, so I did everything right. So here we have another function. The domain here is 0 to pi over 2. And we have f of u to be equal to 2 cosine u plus sine 2u. The first step is to find the first derivative. F prime of u is minus 2 sine u plus 2 cosine 2u, and we have to set that equal to 0. And we solve for u. So minus 2 sine u plus 2 cosine 2u would equal 0, which would mean 2 cosine 2u must equal sine u times 2. So we would have cosine 2u equals sine u. Now we want to know if there is a u that would satisfy this particular equation. I could rewrite this as sine u minus cosine 2u equals 0. And we can use a calculator. Since this is a trigonometric function, it is a bit tricky. So I'll show you using the calculator. Cosine 2u, and the domain is 0 to pi over 2, so that's all I care about. So 0 and pi over 2, and graph I get something like that. So the place where it becomes 0, let me look at negative also. Negative 2 to 2 is right over there, and we would like to know what that value is. So second trace, we want to find the 0. So I'm going to go to the left a bit, enter, and to the right, enter, enter. I get 0.5236. Now there is a different way to find this. We could algebraically solve for this particular value by using trigonometric identities, but I just didn't want to go that far, which is why I simply used the calculator. You are welcome to do the same. Now we'd like to know what happens at u equals 0.5236. So we are going to evaluate the function at 0. So I have 2 cosine 0 plus sine 2 times 0. Cosine 0 is 1, so 2 times 1 is 1. Sine 0 is 0, so we leave it as is. Then we evaluate it at pi over 2. We have 2 cosine pi over 2 plus sine 2 times pi over 2. Cosine pi over 2 is 0, so 2 times 0 is 0. The 2's would get cancelled, and we would have sine pi. And sine pi is 0, so we get 0. We have to evaluate at the critical number, which is 0.5236. So make sure you have it in radians mode. 2 cosine 0.5236 plus sine 2 times 0.5236. Enter. You get 2.5981. So it seems like at 0 the function is at 2, at 0.5236 it's going up to 2.5, and when we get to pi over 2, which is about 1.5 or 1.07, it is coming down that way. So the critical value that we found would correspond to an absolute maximum. And f of 0.5236 is equal to 2.5981. And the absolute minimum is at u equals pi over 2. And f of pi over 2 is 0. Now keep in mind that absolute maximum can also be called a local maximum, because on an interval it is the maximum, but I can't do the same over here because that is an endpoint. Let's see if we get this using the calculator. So the function that we have, the original function, is 2 cosine x plus sine 2x. And I'm going to graph that between 0 and pi over 2, 1.57. We have that right. Everything seems to be positive for the y value, so I'm just going to put from 0 all the way up to, say, 4 and graph that. It's going up and it is coming down, and that point where we have a peak is the absolute max that I drew earlier. That should be x, not t. So now we have a function that is logarithmic, and f of x is equal to ln x squared plus 4x plus 1. And the domain is -3 to 3. So the first step is to find the derivative, f prime of x. So we have to use chain rule. If we treat that as x, we would have 1 over x squared plus 4x plus 1 multiplied by the derivative of that, which is 2x plus 4. Next step, we set that equal to 0 and solve for the critical number or critical value. Which would imply 2x plus 4 divided by x squared plus 4x plus 1 equals 0, which would mean 2x is equal to, well, 2x plus 4 is equal to 0. Which would imply 2x is equal to -4 and x is equal to -2. And that is within the domain of the function, so we can proceed and see if that is a minimum or a maximum. So to do that, I am going to plug in f of -3, which is ln of -3 squared, plus 4 times -3, plus 3, oh, plus 1, I'm sorry, which is ln of 9 minus 12 plus 1. And for that particular value, it doesn't exist because we have ln of a negative number. So that doesn't work. So let's look at the critical number. F of -2, we have ln of -2 squared plus 4 times -2 plus 1, and still we have -4 plus 4 minus 8 plus 1. We get ln of -4. That is undefined also. When I plug in 0, I have ln of 0 squared plus 4 times 0 plus 1. I end up getting ln of 1, which is 0. So it seems like we don't have anything defined on the left hand side, and the smallest value is at 0, and it goes all the way up to 3. So f of 3 would be equal to ln of 3 squared plus 4 times 3 plus 1, which is ln of 9 plus 12, which is 21, and I have ln of 22. So what is the absolute maximum? the absolute maximum is at 3, ln of 22. The absolute minimum is at 0, 0. The reason being, the other values do not exist. Even though we have a critical number, that's fine. Critical number is where the derivative is 0, or it simply doesn't exist. And we got -2, but the function doesn't exist at -2. So let's see if this works out. The derivative exists, but the function doesn't exist. So let's graph this and see if our interpretation is right. So ln x squared plus 4x plus 1. I'm going to graph it between -3 and +3, and we'll see what happens. Graph. And as you can see, my graph is correct, and as I mentioned, it's just going to go toward -infinity because it is undefined. So the proper value that we can say here, excuse me, I made a mistake in concluding the absolute minimum. The absolute minimum doesn't exist because the curve is going to keep on going toward -infinity. So we have an absolute maximum, but an absolute minimum doesn't exist. So we can simply use calculus to identify the minima and the maxima using critical numbers. But at times, the calculator is your friend. You could verify the answers using a calculator.